Well, the British Museum have asked me here today to date this Egyptian mummy. It's of a priestess who lived and died in Thebes, they think about 1000 BC, and they believe this because of the style of decoration on the sarcophagus and the way that the mummy's actually been wrapped. And the technique I'm actually going to be using is radiocarbon dating.
All living things contain 3 types of carbon atom. They are chemically identical, but their total mass is different. They are isotopes of carbon. 99% of carbon atoms have 12 particles in their nucleus. This is their mass number. They have 6 protons and 6 neutrons. But there are other kinds of carbon atoms. 1% of carbon atoms have a mass number of 13. They've still got 6 protons, but instead of 6 neutrons, they have 7. And finally, 1 in a million carbon atoms is radioactive. This means that their nucleus is unstable. The mass number of these radioactive atoms is 14. Again, they have 6 protons, but these unstable atoms have 8 neutrons. Excess neutrons make the nucleus break up. It emits radiation and changes to form a nitrogen nucleus. It's these radioactive carbon atoms that are used in the carbon dating of the mummy wrapping.
So what I'm here to do today is just to remove a small sample from the actual wrapping, and I noticed there's a small piece of it that's come very loose, it's almost off, so I'm actually just here to remove it with my scalpel and take it away to Oxford for analysis. And there it comes.
Cosmic rays from outer space are constantly bombarding the Earth. Occasionally, they collide with a nitrogen atom in the atmosphere to form carbon-14. The carbon-14 immediately combines with oxygen to form carbon dioxide. This radioactive carbon dioxide finds its way into plants. Plants are eaten by animals and humans.
Well, radiocarbon dating is applicable to anything organic, anything that's lived really between about 200 years ago and less than about 50,000 years ago. And the principle is fairly simple. Anything that's living or once lived exchanges carbon with the atmosphere. And of course, when the organism dies, that exchange ceases. And of course, that applies just as much to the plants that have gone to produce this textile, so that's where this is particularly relevant. And another material that's particularly susceptible to radiocarbon dating is, of course, bone. Bone's constructed of collagen, of protein, and it's that protein that contains the carbon. And this is one we have here from a medieval leper from a cemetery, a leper cemetery in East Anglia, which again falls into the range of radiocarbon dating.
The amount of carbon-14 in a dead body is less than in a living body. This is because radioactive carbon-14 is decaying and isn't being replaced. Scientists have calculated that it takes 5,700 years for carbon-14 to decay by half. This is called the half-life of carbon-14. It would take another 5,700 years for it to decay by half again, and again, and again. If we plot the half-life as a graph, with the amount of carbon-14 on the vertical axis and time on the horizontal axis, it will look like this. Using the half-life graph, scientists can carbon date the mummy, but first the mummy wrapping must be cleaned.
We just need to get rid of all the pieces of dust and so on, so we've eliminated everything except the actual cellulose that the wrapping is actually made from. Hi Jill.
Hello.
Here's the sample, it's over to you.
Okay, thank you.
Yeah.
A small sample of mummy wrapping is placed in a combustion chamber, where it is burnt and converted into carbon dioxide gas. The gas is sealed in a glass tube. All the carbon atoms from the wrapping, including the radioactive ones, are now trapped in this tube.
Well, our sample of mummy wrapping has now been reduced to an ampule of CO2 gas, which I'm actually going to inject into the machine. And this is where we actually insert that ampule, and what we want to be careful about is that we don't introduce any contaminating carbon. So we put it in this sealed tube, and then we simply wobble it to break the ampule and release that gas into the system.
This machine is called a mass spectrometer. It uses powerful magnetic fields to sort out and measure carbon-12, carbon-13 and carbon-14.
Now, what the mass spectrometer has actually done is measured directly the amounts, counted the amounts of C14, 13 and 12 in the sample. And here it is just come up on the screen. This is the one we're concerned with. And you can see the mummy wrapping here has 69% of its original carbon left. In other words, it's lost about 31% of the carbon it would have had in life. And from this, the computer's worked out that its actual age in radiocarbon years ago is 2,940.
The computer has calculated that there is only 69% of the original radioactive carbon-14 left in the mummy. That corresponds with the yellow line on the graph, which gives us the time of burial as 2,940 years ago.